The first lesson that we will tackle is about factoring. But before we proceed, let's know first our target for this lesson or our learning objectives. So at the end of this video, you are expected to factor the given polynomials by finding the common monomial factor by difference of two squares, sum and difference of two cubes, perfect square trinomials, and general trinomials. Second, to appreciate the concept about factoring polynomials. Third, find pleasure in working with numbers. So for you to understand our first lesson, I have here the definition of factoring. So factoring is the reverse of multiplication. It is also a process of finding the factors of an expression. So the first type of factoring that we will discuss is factoring with common monomial factor. So find the GCF of 15m raised to the 4th power, 9m squared, and 12m raised to the 4th power. So let's have a review first on how to get a GCF. And to find the GCF of a set of numbers, we need to list all the factors of each number. But how about a variable raised to an exponent? So a variable raised to an exponent, it means that a variable is multiplied by itself. So the factors of 15m raised to the 4th power are 1, 3, 5, 15, m times m times m times m. So m raised to the 4th power, it means that m is multiplied 4 times. So how about 9m squared? So the factors are 1, 3, 9, m times m. And 12m raised to the 4th power, the factors are 1, 2, 3, 4, 6, 12m times m times m times m. So what did you observe? Do you see the same number in each set of factors? Because 3 is the greatest factor that appears on the list, 3 is the GCF, and we have 2m. So the GCF is 3m squared. Now let's proceed to our second example. Factor the common monomial factor out of each expression. So we have here 5x plus 15. So to factor the GCF out of a polynomial, we do the following steps. So first, we need to find the GCF of all the terms in the polynomial. So we have here two terms. So we have the first term, which is 5x, and the second term is 15. So now let's get the list of all the factor of each number. So 5x, the factors are 5 times x. 15, the factors are 1, 3, 5, and 15. So as you notice here, the greatest common factor is 5. So our second step is to divide to each term to find the other factor. So 5x divided by 5 is x, while 15 divided by 5 is 3. So our factored form is 5 times the quantity of x plus 3. Now, how about the factor of 2x squared plus 6x? So the first step is to find the GCF, and our GCF is 2x. And the second step is to divide each term to find the other factor. So 2x squared divided by 2x is x, while 6x divided by 2x is 3. Now let's check it if we got the correct answer. Let's multiply 2x by x and 2x by 3. So 2x times x is 2x squared, and 2x times 3 is 6x. For our fourth step, let's factor 10y raised to the 5th power minus 8y raised to the 4th power plus 2y squared. So our first step is to find the GCF, and our GCF is 2y squared. So our second step is to divide each term to find the other factor. So all of our terms will be divided by 2y squared. Then 10y to the 5th power divided by 2y squared is 5y cubed. And negative 8y to the fourth power divided by 2y squared is negative 4y squared. And 2y squared divided by 2y squared is 1. So our factored form is 2y squared times the quantity of 5y cubed minus 4y squared plus 1. Now let's discuss factoring by grouping terms, and we also need to follow steps here for factoring by grouping. So first, we need to group the terms into two groups. So let's group the first two terms together and the last two terms together. So our second step is to use the rules for GCF to factor this. So the GCF of x cubed plus x squared is x squared, while the GCF of 2x plus 2 is 2. Now after finding the GCF, let's divide to each term to find the other factor. So x cubed divided by x squared is x, and x squared divided by x squared is 1. Now let's proceed to the second group. 2x divided by 2 is x, and 2 divided by 2 is 1. So what have you noticed? Do you see the same number in this set of factors? So for our third step, let's factor out the GCF again, or the common binomial. So for our answer, let's take the common term, which is x plus 1, and the GCF, which is x squared plus 2. So our factored form is x plus 1 times the quantity of x squared plus 2. Let's try another example. So we need to factor 3xy minus 21y plus 5x minus 35. So the first step is to group the terms into two groups. So we have 3xy minus 21y and 5x minus 35. The second step, we need to factor out GCF from each group. So our GCF is 3y, then 3xy divided by 3y is x, and 21y divided by 3y is 7. Now let's proceed to the second group. The GCF is 5, so 5x divided by 5 is x, and negative 35 divided by 5 is negative 7. Now let's proceed to the third step. We need to factor out GCF again, and as you notice here, the green parentheses are the same, so it's the common factor. So for our answer, it is x minus 7 times the quantity of 3y plus 5. For our third example, 15x minus 3xy plus 4y minus 20, let's group the terms into two groups. Then we need to factor out GCF from each group. So our GCF for the first group is 3x, and if we divided the term by the GCF, we got 5 minus y. The same with the second group. Our GCF is 4. We need to divide the term by 4, and we get y minus 5. So if you observe, the factor in parentheses is 5 minus y and y minus 5. So we need to change the sign to make it the same. So our answer is 5 minus y times the quantity of 3x minus 4. Let's discuss factoring difference of two squares. At some point in your study of algebra, you'll be asked to factor expressions by recognizing some special patterns. The difference of two squares is one of the most common, and the good news is this form is very easy to identify. Look at the given form. Whenever you have a binomial with each term being squared, having an exponent of 2, and they have subtraction as a middle sign, you are guaranteed to have the case of difference of two squares. So the formula here should provide an understanding of this concept. We have a squared minus b squared, which has an exponent of 2, and the middle operation is subtraction. So after verifying that you have a difference of two squares, You can now factor it out as a product of two binomials with alternating signs in the middle, positive and negative. So, a squared minus b squared is equals to the quantity of a minus b times the quantity of a plus b, or a plus b times the quantity of a minus b. So remember, the order does not matter. For our first example, let's factor x squared minus 25. So we need to find the square roots of the two terms that are perfect square. The square root of x squared is x, and the square root of 25 is 5. Then we need to write the factorization as the sum and difference of the square roots. The sum of the square root is x plus 5, and the difference between the roots is x minus 5. So, x squared minus 25, our answer is x plus 5 times the quantity of x minus 5. For our second example, let's factor 16a squared minus 9. So first, let's find the square roots of the two terms that are perfect square. The square root of 16a squared is 4a, and the square root of 9 is 3. Then write the factorization as the sum and difference of the square roots. So the answer is 4a plus 3 times the quantity of 4a minus 3. For the next example, we have here the quantity of 2 minus b squared minus 9. As you can see here, we have two perfect square. So the square root of 2 minus b squared is 2 minus b, and the square root of 9 is 3. So for our answer, it is the quantity of 2 minus b minus 3 times the quantity of 2 minus b plus 3. Now let's proceed to factoring sum and difference of two cubes. So here are the things that we need to remember about factoring sum and difference of two cubes. So it has two terms. The terms are separated by a positive or negative sign. So each term is a perfect cube. So look at the given term. A cube plus b cube and a cube minus b cube. It has two terms. The terms are separated by positive and negative sign. And each term is a perfect cube. So here is the formula to factor the sum of two cubes. So a cube plus b cube is equals to the quantity of a plus b times the quantity of a squared minus ab plus b squared. The same with a cube minus b cube. It is equals to the quantity of a minus b times the quantity of a squared plus ab plus b squared. So we have here the same sign and the opposite sign, and the sign of the last term is always positive. The same with a cube minus b cube. We have here the same sign and the opposite sign here, and always positive for the last term. Now we know how to get the signs. Let's work on what goes inside. So we have a cube plus b cube. We need to get the cube root of our first term. So the cube root of a cube is a. The cube root of our second term is b. And we need to get the product of cube root of first term and cube root of second term. So a times b is equals to ab. And we need to square this term to get this term. So a squared. And also, we need to square this term to get this term, which is b squared. Now, let's have another example. So x cubed minus 125. So we need to get the cube root of our first term, so x cubed. So the answer is x. So the cube root of our second term, the cube root of 125 is 5. So the product of cube root of first term and cube root of second term, so x times 5 is equals to 5x. To get this term, we need to square x squared. Next, to get this term, we need to square 5. So 5 squared is equals to 25. 8x cubed minus 27, we need to get the cube root of our first term. So the cube root of 8x cubed is 2x. The cube root of second term, which is 27, is 3. And to get this term, we need to get the product of cube root of first term and cube root of second term. So 2x times 3 is 6x. We need to square this term to get this term. So 2x squared is 4x squared. We need to square 3, so the answer is 9. Factoring perfect square trinomials. Before you can factor a perfect square trinomial, you have to learn to recognize it. So for our first example, x squared plus 10x plus 25. So the first term must be a perfect square. So the square root of x squared is equals to x. The last term must be a perfect square. The square root of 25 is equals to 5. And the middle term must be twice the product of the square root of the first and the last term. So 5 times x, we need to multiply it by 2, and that's 10x. So the answer is x plus 5 squared. So if you have a perfect square trinomial, it is easy to factor. We just need to take the square root of our first term and take the square root of the last term, use the sign of the middle term, put in parentheses, and square the result. Here is another example. So a squared plus 8a plus 16. So the square root of our first term is a. And the square root of our last term, which is 16, is 4. The sign of the middle term is positive, so we need to put positive in the parentheses and square the result. So the answer is a plus 4 squared. For our last example, we have here 9a squared plus 6a plus 1. So we need to get the square root of our first term. So 9a squared. So the answer is 3a. The square root of our last term, which is 1, is 1. So we need to get the sign of the middle term. And since this is positive, so we need to put positive in the parentheses, and we need to square the result. So the answer is 3a plus 1 squared. Now let's discuss factoring general or quadratic trinomials. In factoring quadratic trinomials, we need to remember the following. First, factor the first term of the trinomial and write these factors as the first terms of the factors. Second, list down all the factors of the last term. Third, identify which factor pair sums up the middle term. Then, write each factor in the pairs as the last term of the binomial factors. So for our first example, a squared plus 5a plus 4. So for us to easily answer this, we need to follow the steps. First, we need to factor the first term. Our first term is a squared. A and a is our factor. Next, we need to list down the factor of the last term, which is 4. And we need to consider the numerical coefficient of the middle term, which is 5. We need to identify the two factors whose sum gives the number in the middle. And the factor is 4 and 1. Next, we need to multiply. A times 4 is equals to 4a. A times 1 is equals to a. And for our last step, we need to write each factor in the pair as the last term of the binomial factors. So a plus 1 and a plus 4. Our next example is x squared minus 5x minus 24. First, we need to factor our first term, which is x squared. So we have x and x. And then we need to factor our last term, but we need to consider the numerical coefficient of the middle term. So the pair is negative 8 and 3. If we add the two factors, we will come up with the numerical coefficient of the middle term, which is 5. Which is negative 5. Then we need to multiply the first two factor. X times negative 8 is equals to negative 8x, and x times 3 is equals to 3x. If we simplify negative 8x plus 3x, the answer is negative 5x, which is our middle term. Now, write each factor in the pair as the last term of the binomial factor. So we have the quantity of x plus 3 and the quantity of x minus 8. Next example, we have 2x squared minus 7x plus 6. First, we need to factor the first term, which is 2x squared. So we have 2x and x. We need to factor the last term, which is 6. We need to consider the numerical coefficient of the middle term, which is negative 7. So we come up with negative 2 and negative 3. Once we multiply the first two factor, so 2x times negative 2, we have negative 4x. X times negative 3, we have negative 3x. So if we add negative 4x and negative 3x, we will come up with the middle term, which is negative 7x. Now, let's write each factor in the pair as the last term of the binomial factors. So 2x, the quantity of 2x minus 3, and the quantity of x minus 2. Okay, our last example, we have 4y squared plus 12y plus 5. So first, we need to factor our first term, which is 4y squared. So we have here 2y and 2y. And then we need to factor the last term, which is 5. So we need to consider the coefficient in the middle term, which is 12. And we have here 5 and 1 as our factor. So if we multiply the first two factor, 2y times 5 is equals to 10y, and then 2y times 1 is equals to 2y. Then if we add 10y and 2y, we will get our middle term, which is 12y. Next, we need to write each factor in the pair as the last term of the binomial factors. So we have here the quantity of 2y plus 1 and the quantity of 2y plus 5. Now let's discuss about factoring completely. So this lesson, it is not only focusing on factoring a polynomial using a single pattern. So it gives techniques to factor certain types of polynomials. So this lesson explains how to factor completely by combining the different types of factoring. Before we proceed to our first example, I will give you the three-step process of factoring completely. First, factor a GCF from the expression if possible. Second, factor a trinomial if possible. Third, factor a difference between two squares as many times as possible. So in our first example, we have here 2x squared minus 8. So first, we need to factor a GCF. So we have 2 and 8. We all know that 2 and 8, the GCF is 2. So we can simplify. We will come up with 2 times the quantity of x squared minus 4. And then right after that, as we notice, x squared minus 4 is still factorable. So we need to identify what factoring is applicable in this given expression. So we can use the difference between two squares, and the result is x plus 2 times the quantity of x minus 2. And then we need to copy 2. So for our factored form, 2 times the quantity of x plus 2 times x minus 2. For our second example, so x cubed plus 5x squared plus 6x. So our first step is to factor a GCF. So as you notice here, we have 3 terms and we have a GCF of x. So we come up with x times the quantity of x squared plus 5x plus 6. And then after that, as we can see here, we still have x squared plus 5x plus 6, which is still factorable. So we need to identify what factoring is applicable in this given expression. So we can use factoring general or quadratic trinomials. So we can come up with x plus 2 times the quantity of x plus 3, and then we just only need to copy x. Next example, we have 2x raised to the 4th power minus 32. Our first step is to get the GCF if possible. Since we have 2 and 32 here, we all know that the GCF is 2. So that's why we come up with 2 times the quantity of x squared minus 16. And then take a look at the given expression if we can still factor it. Since x squared minus 16 is still factorable, we need to identify what factoring is applicable. And we can use factoring difference of two squares. So we just only need to copy 2 and then simplify x squared minus 16. We will come up with x squared plus 4 times the quantity of x squared minus 4. Then right after that, observe the given expression if we can still factor it. So just copy 2, and then x squared plus 4 is not factorable, so we just only need to copy it, and x squared minus 4 is still factorable, and we need to identify the factoring, and that is factoring difference of two squares. That's why we come up with x plus 2 times the quantity of x minus 2. Applications of special products and factors. The longest side of a right triangle is 2 more than the shortest side. The middle side is 1 more than the shortest side. Find the lengths of the sides of the triangle. Our representation, let x be the shortest side, x plus 1 be the middle side, x plus 2 be the longest side. For our equation, x plus 1 plus x plus 2 is equals to 0. And for our solution, x plus 1 plus x plus 3 is equals to 0. We need to combine like terms, so 3x plus 3 is equals to 0. And we need to isolate the variable. So 3x is equals to negative 3, divide both side by 3. So x is equals to negative 1, or the absolute value is 1. So to get the length of the sides of a triangle, we need to substitute our answer to the given expression. Since the shortest side is x, so our shortest side is 1. The middle side is x plus 1, so we need to substitute 1 plus 1 is equals to 2. For our longest side, so the expression is x plus 2, so we need to substitute 1 plus 2 is equals to 3. The next problem, the product of two consecutive even integers is 528. Find the value of each integer. For representation, let n the first integer, let n plus 2 the second integer. And since we need to find the product of two consecutive even integers, so first integer multiplied by the second integer is equals to 528. Or n times the quantity of n plus 2 is equals to 528. So if we simplify it, we will come up with the equation of n squared plus 2n is equals to 528, or n squared plus 2n minus 528 is equals to 0. For our solution, here we need to use factoring general or quadratic trinomials. So we will come up with n plus 24 times the quantity of n minus 2 is equals to 0. We need to simplify it. N plus 24 is equals to 0, or n is equals to negative 24. And n minus 22 is equals to 0, or n is equals to 22. So for our answer, if n is equals to negative 24, then the second integer is n plus 2, or negative 24 plus 2 is equals to negative 22. So the two integers are negative 24 and negative 22. If n is 22, then the second integer is n plus 2, or 22 plus 2 is equals to 24. So the two integers are 22 and 24. Another problem, let an integer be represented by x. Find, in terms of x, the product of three consecutive integers starting with x. Since we are dealing with three consecutive integers, so the product will be x multiplied by x plus 1 multiplied by x plus 2. So the answer will be x cubed plus 3x squared plus 2x. Another problem, the side of a cube is represented by x plus 1. Find, in terms of x, the volume of the cube. So the formula in getting the volume is length times width times height. And we can find it by multiplying the side 3 times. So x plus 1 multiplied by itself 3 times. If we simplify the two expression first, so x plus 1 multiplied by x plus 1, the answer is x squared plus 2x plus 1. And then multiply by another x plus 1, the answer is x cubed plus 3x squared plus 3x plus 1 cubic units. For our last problem, write a variable expression for the area of a square whose side is x plus 8. And the answer is the quantity of x plus 8 squared.